Hello, Hacktivity. Welcome to the 2016 edition. I was asked to give this opening speech, and I have to start with a terrible confession. Unlike some experts and thought leaders in this field, I cannot see the future, unfortunately. Back in 2003, when I got to the first Hacktivity ever in Tatabánya, there were like 50 of us gathering there. I couldn't have imagined that I will be standing on the stage and giving this opening speech to you. So there were no way I could see that. Also, I couldn't see that today in 2016 I could go online and just pay for the exploits of the world's most advanced intelligence agency using untraceable cryptocurrencies, for example. Also, I couldn't see that investment companies will ally hackers in order to bring down healthcare manufacturers because their pacemakers are vulnerable. Look up the Senju story, it's quite amazing. Also, I couldn't have imagined that the US government will state officially that foreign hackers are tinkering with the presidential election process. So it's a quite amazing time, I think, that we are living right now, and it seems that our favorite cyberpunk novels are coming into reality. But as amazing it is, it's also quite terrifying. So we feel, at least I feel, that we should do something about this whole situation, and there are challenges ahead of us which we have to solve, and challenges that we are not yet quite prepared of. So here you are at Hacktivity 2016. How this conference can help you to achieve these goals, to solve these problems, to foresee these problems, and finally solve them. Well, I talked to many of you, many of speakers before, and one thing about Hacktivity that seems quite unique, so to say, among all these different information security conferences is what I like to call professional diversity. So please take a look around yourself right now. Take a look at the people who are sitting or standing next to you, because those people are most probably having a quite different professional background, quite different professional experience that they can share. And that's why you can most probably learn something from them, get some new perspectives, and also there is a high chance that you can also teach something to them also. So what I want to ask you in this opening speech is to take this opportunity to cooperate, to talk to each other, have conversations, think about new things, solutions together. And as a program committee member, I like to encourage you to think about things that you will be able to present next year at this very stage. About presentations of this year. So it's also very important to not just to listen to the presentations and the workshops and the trainings, but also to actively participate by asking questions and telling your opinions, sharing your experience with the presenters also, and also your peers, of course. This is what makes a conference more than just, downloading videos from YouTube and watching all the clever stuff that clever people say. Now you have the opportunity to actually talk to those people in person and to talk to each other. And I think that's the salt and pepper of every information security event. For this edition of Hacktivity, as always, we try to bring together topics that we feel are most relevant today. For example, the security of smart devices, iDevices. And we try to bring some presentations which will be about the future, those technologies, techniques, and problems that will shape our next couple of years or maybe decades. An example of that are microarchitectural side channel attacks, for example, that will be presented tomorrow. So we hope that this presentation will serve as a good base to give you a line of thought, some ideas that you can discuss and collaborate about, and share experiences from different kinds of defense. So some of you work in defense, some of you work in offense, and I think it will be quite beneficial to bring these two teams, the red teams and the blue teams, together, and I think Hacktivity will be a quite nice opportunity to do that. And to give you an example of how powerful that combined offensive and defensive thinking can be, I'd like to introduce our first keynote speaker, who killed probably a whole bunch of bugs of your cell phones that you're keeping in your pocket right now, and also demonstrated a real nice exploit against them. So he's a very special guy, and it's my pleasure to introduce you a former Pwn2 mobile winner and Pony nominee, Dániel Komaromy. Please give him a huge round of applause.
Good morning, everyone. Thank you. How about a round of applause for Buharata, right? That was great. So the security aspect of cyber is very, very tough. Maybe not even doable, okay? So that's what I'm here to talk to you about today. And first of all, I would like to thank the organizers, obviously, for giving me this opportunity to come here to talk to you today about this topic, and especially Buharata, who actually gave me the idea for this keynote originally. This goes back about a year and a half, I think. We were having a discussion about, how come, and I think that's a discussion pretty much everybody has had. How come you have all these big companies, your billion-dollar companies, you would think, they have all the resources, and still, again and again, they end up getting owned, sometimes by, really silly bugs. And there's this popular sentiment that, well, that's because they don't care. Surely if they cared, you wouldn't have these kind of problems. And I think this was about the time, actually, when, Apple had that infamous go-to-fail bug. And, that's particularly, the type of thing. And I think everybody has seen a disclosure like this. When you look at the bug and you just think to yourself, really? Like, seriously, you have a bug like that? That has to mean that, you're not, taking this seriously. And at the time, I was still working for Qualcomm, so doing exactly this type of defensive product security work. So I've come to it with some years of experience of I guess you're trying to do an honest job, but you again and again see that certain things just kind of get in the way of you actually being able to succeed in coming up with a what you would call a secure product, I guess. So when we talked about that, I thought more about that and kind of came up with, I guess, this presentation, which of course is mostly going to be opinion, not so much fact. So obviously I invite you to challenge any of the assumptions here. Hopefully we have time for some discussion at the end, or if not, then in the speaker's corner, I guess. So with that, let's get started. And I would like to go to the title a little bit. So that's the original quote that you see. Bear Bryant, of course, is not a security practitioner in the CISSP mold. He's one of the most famous college football coaches. He used to coach at University of Alabama. And so this quote is attributed to him, and he sort of captured this idea that, okay, offense is flashy, and, it's what gets you the news articles. I guess that's sort of true for security as well. But at the end of the day, defense, has these built-in advantages. So if you take it seriously, eventually you win with defense. And I think that's interesting because when you look at security, that's what I argue here today. you actually sort of turn that inside out. And if you look at the game that we're trying to play, it turns out that, the odds are really not in the favor of defense. So let's talk about why that is. But I think if I try to give you this theory that, well, offense is winning, and here's why, but first I should somehow, prove it to you that this is true. So let's start there. And the first thing we have to talk about is, okay, we sort of have to define, okay, what is this game that we're playing that I claim that, offense is winning? And I think that's exactly where the problems start, because for the most part, from the offensive side, it's kind of, I think, usually clear what game you're trying to play. Essentially, you have some asset, you want to compromise some asset, that's your game. Or, you essentially want to, make money, and that's your game. So sort of your goals are clear. And obviously that means that, you can develop some strategy and you know what you want to do since you know what you want to achieve. But when it comes to defense, I think what we mostly have is, let me see if I can succeed at starting the gift. Yes, okay. By the way, that's the high point of the presentation, I think, that cat. So, really cherish that. It's all downhill from here. So I think this is one of the games that defenders try to play, right? The whack-a-mole. Okay, our goal is to get rid of all the bugs. Or, they say get rid of most of the bugs. Or, find the bugs before offense and these things. And I think that that's just basically a losing strategy for a number of reasons. And I'll talk to you about why, but I think most people sort of tend to agree that, that's not what we should be doing. And there's this more popular sentiment more recently that, oh, no, that's not the game we should play. The game we should play is, raise the attacker costs, right? There's lots of talks about this concept that, what you have to go after is, make it more expensive for attackers. And that at some point, that's the concept, I guess, you price out attackers and they're going to say, oh, I give up, right? I'm not going to do it because now it's too expensive. And what I think is that I think that's also essentially an inherently flawed strategy. And the reason for it is, first of all, you have to decide, okay, what is this attacker that you're trying to price out even? And you will hopefully see from some of the comments I make later that this is a very big problem, especially in the mobile field and the embedded field, that there's this, fog of war over, okay, who's your attacker even? And then the bigger problem is, even if you would stick to some, attacker type that you care about, is somehow you would have to actually know, first of all, how much whatever you do is raising this mythical price of exploitation. So you would have to be able to assign some kind of value to what you just did. And secondly, you would have to know when you're pricing anybody out. And I think that's the biggest problem, that I think there's virtually no evidence that you actually price attackers out. I think what we're seeing more is, as targets get harder, the price for owning them is getting higher. I think if you've followed, in recent years now, there's slowly more public information on, how much money you can make if you're playing offense. And what you're saying is that, okay, yeah, maybe some targets are getting in some kind of objective way harder to exploit, but the return on investment on them is, keeping up with that. So there's not really this evidence that, but if you look at, for example, obviously Jonathan here is talking about iOS. So if you look at, okay, is it harder now somehow to exploit, an iPhone over the browser than it was, in 2007? I think in an objective way we can say, yeah, certainly. But, I mean, has the price of, selling iOS exploits kept up with that increase of difficulty, or has it even, surpassed that? And I would argue that that's true. And at the end of the day, that means that the game hasn't gotten worse for attackers. In many ways, it's gotten much better for them. Now they are making, even better in ROI. So this kind of means that, to begin with, the games that defensive, players are trying to play is, stacked against them. Well, okay, so if that would be true, what I said, then there should be, some kind of data that actually shows that, well, and the end result is you got all these bugs. So I suppose I should somehow, show that. Well, we sort of come up against the problem, when we start focusing on, mobile and embedded space. And that's a problem of, telemetry data. So what I mean by that, by telemetry is your availability to actually see the attacks in the wild and be able to say, okay, here you go. These are the actual, attacks that are happening. And so, I use that to guide, what I'm doing. And I think, traditionally in the desktop world and server world, there's a lot more of that data available, right? But in the mobile space, historically, that's just not been the case. That's a picture, by the way, I took straight from presentation by Vincenzo Iozzo, which is called The Tale of Mobile Threats. It's a keynote he gave like 6 years ago, I think. You can find the slides online. It's a great talk. So, and it's finally still very relevant today. So I advise you to check it out. But the bottom line is, okay, so there's just not really a lot of data on the real attacks. And I think, there's a couple of reasons for this. But I think the biggest problem is that a lot of the types of attacks that you're supposed to care about when you think about mobile or embedded are the types that are actually really hard to even get our telemetry data for. And that's because you're supposed to care about, local attacks, proximity attacks, physical attacks, things like this. And that's not the kind of thing where, hey, I set up my honeypot and I'm also going to get those server requests. Like you look at this, this is the bug du jour, right? The copy on write Linux kernel exploit or bug that just came out yesterday. Okay, how was that found, right? Some guy saw it in his packet capture data, right? So this is something that, works as a detection mechanism in the desktop world and in the server world, where inherently everything is, remote and over a network that we have the good tools to analyze. But when it comes to mobile, like I said, a lot of things are local. And then the second part is that a lot of things are going over networks that most of us are totally blind to. Obviously, I'm talking about the carrier networks. And historically, there's just not been built out this infrastructure that allows vendors to actually get access to, okay, well, this is what's happening on the devices that I care about. Well, I obviously have to sort of interject my own line of thought here a little bit, since you could think to yourself, hey, come on, you're conveniently putting aside, some obvious counter-arguments. So if you look at Google, I mean, they talk a lot about, all this massive infrastructure they've built out, for example, to know what's going on, right? And I'm talking about, if you look at, they gave a presentation at Black Hat in 2015, and then I think most recently, this spring, they updated their annual report on their State of the Security Union. And they talk about how they have these different mechanisms for, detecting untrusted apps and things like this. But I think, the bottom line there that I want to say is that all of that is really just focused, mostly very narrowly on this concept of malicious apps, right? Which obviously is a problem on its own. And I definitely concede that we have, that there's definitely telemetry data on that topic. Of course, that by itself is something, on the other hand, that you could argue forever. I think this has been going on for a long time, that, Google says, 0.1% of devices ever get to see a malicious app. It's like a small problem and it's contained and all that. And then, antivirus vendors always say, oh, that's not true at all. Look at, this malicious app we found in Google Play, this other one. In any case, I wanted to acknowledge this, but more put it to the side, because I think if we wanted to talk about, okay, are there malicious apps in Google Play? I guess we'd be here for, a very long time. But if you start looking at all the other aspects, you start seeing that we have very scarce, resources to actually get telemetry data. So, okay, how about this, mythical, IMSI catchers and, the misbehaving, cell towers and exploitation over basebands. And really, there's just no real trustworthy infrastructure there. And I'm not talking about something for, you, but even for the vendors that will say, okay, are these attacks happening in the wild? And, this is something that I really draw on, and my personal experience. I spent 5 years at Qualcomm, one of the things really focusing on is baseband. And through all that time, I was essentially completely blind to okay, but I mean, is there somebody exploiting basebands? Who's exploiting basebands? Is there any data seeing an actual baseband attack, in the wild? And I mean, if people put up some research on oh yeah, you can do these IMSI catchers, but for the most part, they are more toy examples than real working things. And this list goes on. So if you look at, iPhones, and are iPhones misbehaving, and do we have data on that? And I think pretty much the only case where we would have seen something on this is, Section 9's recently, put out this app, which I thought, that goes in the right direction. And then obviously, Apple shut that down in, a very short amount of time. So we're kind of going back to blind city. And then you have something like Google Safety Net. But again, if you look behind, what is Safety Net? Then what they're doing is, they are essentially trying to detect, known attacks. So when they patch code, even in system services, so not talking about apps, then they add a patch that will not only prevent the bug, but it will say, oh, well, this bug was going to happen, so I'm going to report that. So the obvious problem there is that's not going to do you anything for 0 days. And then there's another problem with this whole thing, which is that, I wouldn't want to stand here and argue that it's impossible to build these things out. In fact, I would definitely, try and encourage vendors, you should try and do more of this. But there's a problem here, which is, be honest. I mean, how many of you even turn on, when you're registering your Google phone and it asks you, hey, would you like to send all this enormous amount of data about how you use your phone? I think this room probably overrepresents the number of people who say, well, yeah, definitely not, thank you. But if you think back about, for example, the scandal that we have with Carrier IQ, I think these are examples that show that, in this sort of more privacy-aware age, this is actually something that's really hard for vendors to push, that, oh, well, now we want to sell this idea to the customers or the end users of, let's say, a phone or a router or whatever, that we will add these seemingly very invasive techniques to your operating system so that we detect a lot more of what's going on here. So it's not only that these systems, don't actually exist. It's also that it's not just a technical problem, but I guess in this state, it's really, I think, a cultural problem to create that. And of course, I should mention that at the end of the day, there's started to be in this, sometimes we sort of get a peek behind the curtain. The Pegasus was an example of this, where, all of a sudden, out of the sky falls, hey, here's actual targeted attack against an iOS browser. And but I think that on the one hand, I think whenever we've seen these, it mostly supports the argument that, well, you see, in the wild, clearly these things are being exploited. But on the other hand, I think for the most part, as data, we can almost dismiss that because it's so, I think it's very small. It's like a drop in the ocean. So, okay, there's just one case. Okay, what does that really tell us? Are we any that much smarter? I think it's a little bit similar with all the disclosures that came out of whistleblowing and stuff like this. That it's not that much data to give you when we're not talking about you had a previous agenda and you thought in your head, oh, I'm sure that's happening, and then you see something like that, you're gonna feel validated and you're gonna think, yeah, I always knew it. I knew it. The NSA is sacking the Germans. I knew it. It's there. I called it. This is true forever. Right? But the problem is that when you're a vendor and you're supposed to be aligning your security strategy to something and make decisions on, we have to drop everything and focus on that, then these type of random data points actually really don't give you all that much. So what I would like to do, in addition to really support this argument that offense actually is winning, even though we are absent of data to show that, in my opinion, is sort of reduce the argument to just say, okay, in my opinion, I posit that, published security research is always a lower bound for the actual capabilities of dedicated attackers. And so the corollary is, if we look at security research and it shows that, all these things are compromised with ease, then what that tells us is, real attackers are, even doing better than that. So, if you give me that, then now I suddenly have a very easy time because, the news is full of this. So I have a couple examples here on this slide and on next, and all of this is from the past 4 months, so it's not even like I had to put all this together from a longer period of time. And when you look at this slide, for example, everything here, these are exactly the type of attacks that, okay, if this is happening or not happening, you're just not going to know. Just look at these problems. These are all local attacks. There's virtually no telemetry capability anywhere right now that would detect these things actually happening, right? But then, okay, those were local. But then there's a whole bunch of things also super recent, that are remote attacks. But again, are interfaces and types of targets that, there's no such infrastructure there. That's actually, I think, the hack about the connected drive in BMWs that was particularly interesting. In the article, they talk long about this problem that, and okay, is this happening in the wild? Well, nobody knows because, well, we have all these statistics from the FBI and, well, there's all these cars stolen in the US and they not exactly know, how, but okay, we don't know. So it's, okay, maybe it's really this type of hacking. Maybe nobody knows, yeah? Okay, now I sound a little bit like, maybe there's no hacking. Maybe it's a 400-pound kid in the basement or whatever it was. But the bottom line is, if we go from, public research, I think, we can deduce this, that, right, offense is winning. So now let's talk about, why that's the case. And I think this is interesting because, okay, I've said all this, right? All right, there's problems with the game and all of this, but the idea is supposed to be that, okay, offense has its own built-in advantages. This is true, for the reasons that we talked a little bit about. But then defense is supposed to have also its advantages. It's supposed to have, you're the owner of the code, so you sort of get to move first. You're a big company with huge resources and all these things. So the concept is supposed to be that, even there's this offensive advantage, you can even that out. But what I've seen and what I believe is that your supposed advantages actually erode for totally different reasons, and that's why in the end, you're not able to even out this offensive advantage that just sort of comes from the game. So what are these problems that mean that defense doesn't have good chances? So I think something that is very important and probably the biggest issue is the reality is the company that makes all this stuff, it's actually never such a big company. This is just simply not true. It sounds like it's true, but what actually happens is, take the Pixel for example, made by Google, right? It's a Google phone. Finally, it's not OEMs, it's not this, it's not that. Now they got their stuff together and made the phone, and it's them, and now it's a Google phone. And that's true, except it's a total black box to them how the OMA DM was done, what the crypto engine is in its hardware design, what the secure word firmware is, what the hypervisor firmware is, what the baseband is, what the image processor is, what the resource power management core is, what the bootloader in the ROM is, what the eMMC firmware is, and this list goes on and on and on. And by the way, also they don't know the keys to sign firmware. And at the end of the day, you end up with, well, some of these critical parts of your stuff that actually, give the keys to the kingdom to attackers, that's not even being developed by some big company at all. It's been developed by some small third-party vendor that's totally absent of all these advantages, like, we're a huge company with resources and history and all of this. And then, Google is just sort of putting all that together. I pick on Google, but it's not necessarily fair. I mean, if you compare it to some other, players, they're in a super position. I mean, if you start talking about cars, then it's way worse, right? Then, a company like Volkswagen or Audi, they make the car, but when you start looking at the ECUs, they essentially didn't make any of that. And all of that is a black box to them that was delivered based on specifications. And they have about as much advantage. And that's the point I want to make, that the idea was supposed to be that you're the defender, you have an advantage when it comes to finding bugs in this thing. But what turns out to be the case is that you are in exactly the same position as the vendor, as some other guy who was going to turn out to be your attacker. It's just some black box to you as well that you have to integrate into your product. And obviously, there's been some high-profile failures essentially stemming from this. I think one of the biggest ones has been, the issues with Red Band that Matthew Solnick has disclosed a couple of years ago at Black Hat, which basically this resulted in like remote jailbreaks in iPhones. So just about, the most high-profile target in mobile. And essentially it came down to, by the way, there's this piece in your iPhone which has a completely remote interface which can be woken up over SMS, and it's super buggy, and Apple didn't even know. But you can give other examples. We have seen a lot of this trust zone research against QC Qualcomm's implementation, and if you look at the actual owner of those phones, so like you say Google, or that thing for them is just another black box, closed source firmware that, they don't particularly own. They just put into their phone and hope, well, this is going to be the root of trust for my full disk encryption. Turns out, it's not so great. Or another great example, I think, is also over this summer. Researchers disclosed these issues with Volkswagens that allowed them to crack the key fobs, essentially remotely open the cars. And what that came down to was, all right, well, that was based on a chip that comes from an XP. And Volkswagen said, well, okay, well, that's an NXP chip. We didn't know. And then the NXP people just said, oh, right, well, yeah, that's a super old version. It's using this, high tag too, but, oh, we have discontinued that forever, and we've been telling customers don't use that. Okay, great. Well, looks like, Volkswagen was not aware of that. So that's, I think, one of the biggest issues. Another big problem, and it's sort of funny because it's almost the exact opposite of this, so it sort of shows that, when you're in defense, you just can't win, is this concept of, well, and it's actually why I think a lot of times vendors fall back to, well, I'm just going to take somebody else's stuff, is that you have to make everything from scratch when you're, making a mobile phone or you're making a car or whatever. A lot of the security problems, and these are non-trivial things to engineer, are not solvable by just use OpenSSL, right? There's no, off-the-shelf, and I'm not talking the type of off-the-shelf where you go to Stack Overflow and you copy-paste, and it's obviously a terrible solution, and you shouldn't have done that. I'm talking about reasonable, good, off-the-shelf advice that you could just follow and do. Instead, you have to build things from scratch, and you should not underestimate the difficulty of doing that. And then the data sort of shows, I think, that, yes, that's hard to do. I think one of the biggest examples of this that we see again and again and again is the problem with entropy, which is, when you're supposed to be designing a router or a phone or, some car ECU, this is really a non-trivial issue that, okay, you have to make a chip out of scratch and you have to design into it some kind of hardware that will always give you great, entropy right at boot time, right? That's not easy to do, especially when you have basically no good model to follow for that. And then you have problems coming out of this. Probably everybody has heard about the Jeep hack that Charlie Miller and Chris Velasek has done. And one of the early things that they were able to do is actually crack the Wi-Fi password, or show that they can crack the Wi-Fi password or in the onboard Wi-Fi that these cars have. And what that went back to was, well, the design for getting early boot time entropy was just really bad. And because of that, the passwords that ended up being generated were useless and easy to crack. So, this is a problem, and there's sort of another aspect to this, which is when I say everything has to be made from scratch, well, even in cases where you think you're doing the right thing, which is to say there is actually, oh, it's not that bad, some consortium or whatever thought about it, and there's a specification, you should follow that. And turns out even when you do that, sometimes those things are just bad, right? So I think one good example of this is, actually this was just published this summer at Usenix. Some researchers showed that the 802.11 group key generation in a lot of routers is completely broken and easy to crack. And turns out why was that? It was because, well, there's a specification for how you generate group keys, but turns out that specification is so broken that if you as a vendor would do that, it would be so slow that it would be unusable. So, of course, all these vendors try to do the right thing, and then we're like, well, this doesn't work at all. Like, I'm not talking about it's not secure, it doesn't work. So now you have to go back and do it from scratch. And, guess what? The various attempts that they came up with, weren't so great. So the next problem, I just want to touch on this briefly because I think it's sort of obvious when you think about it, but it's still an issue, is that, well, there's an aspect of attacks that you're supposed to care about where, normally the common wisdom is that, well, that's when we give up, right? And I'm talking about exactly local attacks. I'm talking about physical access. That's one of the mantras in security, right? If the attacker has physical access, it's game over. They always win, right? Forget it, dude, let's go bowling, right? That's what we learn in school. Yeah, physical access, game over, right? But the problem is when you're making a mobile phone, then, for example, you're supposed to come up with a solution where when somebody's phone is confiscated or, stolen, you can't, it still should be secure against, compromising that phone. And so there you are. You've learned this common wisdom that, yeah, that's a losing game. And then people say, oh, well, yeah, but you're supposed to do it. So, you can see how that's not easy. And, of course, we do see that this, again, ends up failing. I think, again, one of the most recent examples of this has been this whole thing with the passcodes on the iPhones, with this unfortunate San Bernardino case. And then, some months later, this Russian researcher showed that, oh, yeah, by the way, you can clone the NAND. So it's actually, here you go, a couple $100 worth of work to, to get around this. And I think, really, as much as we are, not doing so well in like software-based, exploitation, I think it's becoming increasingly obvious that we are so far away from, in commercial products, robust anything against, physical access attacks. So it's sort of like, well, here's your phone, here's your high-profile thing that you're supposed to be doing well, and there's virtually no indication that you even have a chance of doing that. All right, have fun. And then the next thing. So I think, again, this is something that I think I could not mention, but I do want to defend companies here a little bit. So, people talk about, there's a backdoor, it's because they're nefarious. In my experience, the problem is a lot more, you have some product security team and it's trying to do something, but then the rest of companies doing, different things. One of the biggest things is I like to say, these are not really backdoors, they are debug doors, right? What this is, all right, well, we're putting this product out there, but, we get field reports, we get non-working devices, so we have to actually maintain some ability to go and figure out what's going on when there are things wrong. And, these are non-trivial problems. I mean, this is something that, phone vendors face all the time, that, they put out some product and the network carriers come back and say, yep, no, this is definitely not working properly. I'm not getting 3G at this whatever scenario, it's not working normally. So then you have a finished product and you're supposed to go and, well, debug its baseband. All right, well, if you've locked that phone down completely, then you have a problem. And this is really not easy. When you start thinking about it, well, you could design in some solution where it's somehow perfectly secure, but okay, how are you supposed to do that? Are you going to actually, hold on to some private keys or something that lets you get in? Because then inevitably you get into this cultural problem when people say, oh, yeah, you're playing into the hands of the FBI or whatever. That's why you kept your keys. Or, you could say, well, no, there's a way to do it. Design a system so that when you really have to get in, first it wipes all the user data and resets the phone, and then you can get in. Well, that's great, except, that phone was already working fine in the tests when it was the pristine thing. That's not the problem. The problem is that the carrier is coming back to you and saying, well, this thing here doesn't work. Well, then you can go and wipe it and do your tests, and it's going to work, and, you've achieved exactly nothing. So it's really a non-trivial problem, so you get stuck with it. And the other problem with this, the rest of the companies doing something, is that, there's really a very long, tail of products at a lot of these companies. My favorite example is, did you know that Samsung actually makes tanks, like literal tanks? And the thing I love about this is that recently I talked to somebody at Samsung and I made this joke for him as well. And, he didn't know, right? So I think this gives you an idea of, that you got all these tools, all these things that, actually fall under your umbrella, but a lot of them you're not even aware of. And then there's another aspect of this whole other people are sort of eating your lunch, is that the rest of the ecosystem is doing something else. And here I'm talking mostly about, the type of thing where, you have somebody downstream and then they go customize the thing that you built. I think, people from Google, for example, could, talk about this all day, that they try to build something and then it doesn't matter because then somebody else downstream, compromises that stuff. Well, okay, well, hey, take responsibility for it. So, now go and also look at that. Well, that's great, but now you're looking at a finished product that you also have to literally go to the store to buy. So that means you're exactly in the same position as the attackers, right? So that obviously means that all your built-in advantage is gone. So that doesn't, play very well. And then, another problem is that even if you do all this, well, obviously, you end up with some problems. But the problem with these problems is that sometimes they just never go away. And some old versions, this one of the problems that, old versions just stay relevant seemingly forever. I talked about this NXP issue with the Volkswagens, and that's a great example of this, right? Okay, hey, that's what a blast from the past, right? Oh, here's this product line that we knew it was problematic, but hey, we improved it. That's not what we've been selling for, however, 6 years or whatever. But guess what? It's still the thing in the things that actually, are out there. Again, in the car industry, this is a huge issue because they come much more from a culture of, reliability. So once they pass tests on some, piece, some ECU or whatever, that's going to stay in cars for a really long time. So, that means that if you make a mistake in whatever, 2007, all right, well, that's going to be, staying with you for a really long time. And another issue is, with this bugs never die problem, is that, well, yeah, but you should patch everything, it would say. But I don't want to get into the whole thing about like how patching is hard and all of that, because we definitely don't have another 3 hours. But an aspect of this I want to point out that's actually specifically hard in my experience in fields of mobile and embedded is that, well, one thing you need to have if you want to have any chance of patching properly is regression testing, right? You need to be able to make sure that if you have fixed some problem, then from that point on, all the products you're putting out there don't have that problem anymore, right? Otherwise, these things are going to come back, they're going to crawl back, and you're going to be back where you started. But the problem is, again, we come back to what are the kind of interfaces you're supposed to be protecting. And some of these are actually really hard to regression test for, just in terms of the cost of it. I talked about the entropy. So this idea of, well, okay, now go and do, verify that random number generator is putting out good early boot time entropy on every single type of product you're putting out. Oh, and by the way, also do that for the final products because the OEM might have modified that and do this for everything. That's really hard. Or here's another example. In routers and things like this, people often talk about, well, the problem is that it's so easy to get in at the first place because you have these UART accesses and JTAG and things like that. Okay, so as you're a vendor, you're supposed to be turning that off. Okay, well, this means that from this point on, when you have drawn a line in the sand and said, well, from that point now on, the things that leave the factory, JTAG has to be disabled. Okay, so you're going to take every single product and take it apart and solder on a JTAG header just to make sure, yep, no, it's turned off. And by the way, you're going to do this for everything that you buy from the stores because now you're going to start buying every phone that was made with your chip just to make sure that's the case as well. So, that's not very economical. And even if this was fine, even if you were able to solve your problems properly, even if you were able to say, well, once I patch something, from now on it stays patched, a really big issue is that the patching strategies are completely misaligned, right? I think a big example of this is that you see it is with Google and Qualcomm. So for a long time, none of them were putting out advisories. Then Qualcomm started to put out advisories, and they have this cadence of when they have a bug, they put out an advisory. And then recently Google decided they're also going to put out advisories, and then they have a cadence of monthly doing this, right? And so this is great because this is misaligned. So now what's happening is essentially, again and again and again, Qualcomm is just giving you this like free, hey, here you go, here's a bunch of old days that we fixed, in whatever number of weeks or something, there's actually going to be a patch cycle where hopefully Google is actually going to put out the advisory for that, meaning the fix for that. But in the meantime, here's the bug, just in case somebody cares. And then, this is something I wanted to mention, that there's kind of this, at the end of it, there's this inconvenient truth about what you're supposed to be doing at the end, which is patching, right? Which is that, we have this wisdom or this rule of thumb that, the quote right thing to do is reporting bugs, right? Is the disclosure, and then the wrong thing is hiding bugs or, selling bugs and things like that. But then, unfortunately, that's not what the data shows, right? The data shows that when advisories go out and 0 days become old days, then it's exactly those problems that end up, trickling down into, attacks that you actually see in, say, malware apps and things like that. The privilege escalation things they use. I don't think they are 0 days. I can personally not recall a single case that was documented where, here's a malware app that was found in Google Play Store, and look, it used its own kernel 0 day. What we see instead is, it's old days that was, published by some whatever researcher a long time ago. So kind of even at the end of the day, you're just helping the attackers. And I think, there's another other aspect of this, of course. So why are companies doing this? Why are we disclosing things? I honestly think the biggest reason for this is that, there is a value in it, but that value, I think, is not really a technical value. I think the value is basically you're buying goodwill with that. I think there's this, like I said, there's this expectation you're supposed to be doing it. So that's a good thing to do. And even, when I was working at Qualcomm, I would say, we should be doing that because, that's when people are going to see you in a good light. And I think, there's definitely merit to that. So there's sort of like an economical reason to do it that way. But if you reduce it to sort of our aspect of technically, is this helping you not getting owned? Not really. So we are super running out of time, so I have very little time. But there's just a couple of things I wanted to mention that I think, vendors, in any case, are doing wrong. So we have, at least I try to talk about all these things that, make it really hard for them. But nonetheless, there are things that they are doing themselves that they really shouldn't be doing. I think one of this biggest problem is that, I talked about the fact that there's no telemetry data, so sometimes it's convenient to actually react to these black swans. So the concept of a black swan is, some research result that is so shocking and rare, but the reality of that actually happening in the wild is very little. And I think this happens a lot in security research because, be honest, that's what we as a community value, right? Original awesomeness, right? This happens all the time in desktop. People say here's this super amazing attack chain. By the way, real attackers use Java. So it's a little bit like that, right? And so, in this world, there's no real attackers. We don't see it. And so companies go after these black swans. I think I really debated whether I should say this. Some people will not like it. But honestly, I think stage fright was a little bit an example of this. When, it's like, oh my God, over SMS and all of this. And so huge resources went into that. There's virtually, no evidence that, that's how, androids were, have been or will be, getting going, right? Nonetheless, that's what they were spending the time on. Another problem that I like to pound on, so this is something that people talk about. Oh, yeah, you're wrong, man. That people talk about as a silver bullet. You have to think like an attacker, and then it's all going to be great. And I just wanted to mention this, that I think, I think that's one of those things that sounds great, but it doesn't really make that much sense, in my opinion. The reason for this is that the way attackers think is they want to get it done. So their goal is, they talk about it's a graph, find the one bug and find the way in, right? But as a defender, you can't do that. You cannot play the game where I just had to compromise it. I did it. It's great. We can ship the product now because I found the one exploit. So we're done. There's definitely no other exploits. There was only the easiest way in. There's no second easiest way in. That doesn't work, right? So as a defender, what do you do? Okay, I thought like an attacker. I found the easy exploit. Great. Now let me go back and think like an attacker again and find the second easiest exploit, right? And so at the end of the day, if you will, instead of thinking in lists, you got to end up thinking in lists of graphs, right? Because you're supposed to, find all of them. So, and I'm not saying that's a bad thing for vendors to do, to think about how they look for bugs in that way. I'm just saying that's not a silver bullet at all. And then this is another thing, as I briefly wanted to touch on that. There are, like I've said this before, that for mobile vendors and embedded vendors, there's not a whole lot of things to fall back on, like this is how you're supposed to be doing things. But one of the big things people talk about is the secure development lifecycle, right? And this worked, Bill Gates stopped Windows development in 2003 and all of this, and look at how great it was, and this is what everybody has to do. But, the problem with that is that, that was a product called Windows XP, 13 years ago, and what you're building is a car that has connection interfaces that didn't even exist in technology when Windows XP came out. And for all the reasons that I've talked about, your ecosystem is completely different than Windows XP. And so, what you end up with is that what SDLC is rooted in is that what we're trying to do is make it cheaper to fix bugs, because that's the whole concept, that the earlier you try looking for bugs, it's going to be cheaper to fix bugs. But if you go back to what we talked about in the beginning, with the price elasticity for attackers and all of that, that's not even a good game to play. So even if you master this concept of like, well, I'm fixing bugs cheaper, well, all you're doing is you're playing the whack-a-mole a little bit more economically, which is a losing game, by the way. So, you're losing at a lower cost instead of losing at a higher cost. I suppose that's some kind of win, but, not really ideal. And then I just want to close out with some advice for defenders, I guess. I think this big one, this is probably the biggest one, and I think it sort of naturally follows from everything I was trying to talk about, which is, I think what companies should try and do more is really, pick your poison. What I mean by that is sort of depart a little bit from, we have to fix, all the parts of everything are expected to be, good. And, you see this in advisories all the time, right? We take every report extremely seriously. That's not true, right? That's not true, okay? What you are doing in reality is you're neglecting a whole bunch of stuff. But you're doing that, I guess, as a byproduct. And what I would think, or what I would argue that vendors should be doing is think about, okay, we can't do everything. Come up with some kind of strategy of what you're going to do and try and, cram everything through that. Of course, there's sort of danger in that as well. There's the adage that, when all you have a hammer, everything looks like a nail. But I still think that that's a better strategy. And, I've picked on Google a little bit, but I think at the end of the day, they should be applauded for, clearly, you can see in the type of things that they're doing that they have a concept of like which parts of Android they're more trying to protect, and they're focusing on that. And yes, it's true that some things are left on the side, and as you can see, that's not very good. But at least, they are getting, pretty good at protecting some parts of it. Another example, I think, is like Samsung, with Knox. It's not a perfect thing, but clearly they have made up their mind about like in what type of ways, what are the things they're trying to mitigate, and they're just focusing pretty much on that. And another thing, this is almost sentimental, so I wanted to get this in here, but realistically, I don't think it's something that people will say, oh yeah, right, let's do that. But I think it's still true that, like I was saying before, to the outside, vendors always talk about like, oh, we take everything seriously. But, that's not really true, especially the tune of, guess what? Product security teams have roadmaps. They almost always know at any certain point of time that this current mitigation or whatever that we have, this is not perfect for XYZ reasons. We know that it has these mistakes, and we have it penciled in for 2017 or 2018 or whatever to improve this. But, in their public PR, that's not what they say. You don't really see a paper on Samsung Knox saying, well, this is kind of nice, but there's all these ways that it's bad, right? That's not typical. Here, I would like to assign some credit to Apple, actually. Their security white papers are kind of nicer in this way. So, they don't really shy away from pointing out things that are limits or so. But that's not typical, I think. And I think vendors should do that more. And the big reason for that, and I'm not just trying to say this because that would be nice. It would be nice. But I think a big reason for this, and this is what I've seen again and again when I was on the incident response side of things, is that at the end of the day, it's not economical for you to not do this, because what happens is that you get these random interruptions. So you've assigned your resources to some kind of roadmap where you're expecting you're going to do something later, and then randomly somebody publishes a result which basically boils down to researcher finds out that thing works in exactly the way the vendor always knew it worked, right? Nonetheless, now you have this outside pressure to throw everything in the wind, forget what you've been doing. Now you have to do something else because, now you have to fix this faster. Think about, Tesla and, MCU firmware verification. And so this is really not an economical way to look at, the sparse resources that you have. Of course, if on the other side, if you're being a little bit more honest about like gaps in the stuff that you have, you can forego that a little bit. And then the final point I would like to make is that I think vendors should really do is, going back to the very beginning, this thing that I really like to beat on this, just raise the cost for attackers. I think this is what, in the PAX team, and I think this is a great thing to end on, since obviously, Pipac is from Hungary as well. Long time ago, they wrote this great article on ASLR and the cargo called, insecurity. And what they're essentially talking about is this mantra that anything that makes things harder is good is a complete fallacy. And this idea that any mitigation is a good thing. It's like any PR is good PR, people say. Anything that makes it worse for the attacker, that's good. And I posit that that's not true at all. I think there are a lot of things that, people do and they sort of think, oh yeah, but this is a mitigation. It makes things a little bit harder, so that must be good. But in reality, you're just building up these walls around your product that essentially, at the end of the day, create these safe havens for attackers. So you look at obscurity, you look at firmware encryption. These are things that, if you think back to what I talked about, where you have downstream customizations, you have problems with patching misalignment, and all of these things, you have problems with regression testing. Now, think about having those problems when you've made your product more obscure, when you've added firmware encryption. You have essentially made it a safe haven for the attacker because it's going to be harder for you to fix things. So now, the hard-earned coin is going to, stay there for a longer time. And then the last thing I would like to say that really, I think, contrasting SDLC vendors should build in a little bit is, I think it would be good to have a departure from this work process where security has to be baked in. But people use that as a convenient way to say security doesn't get its own time. We don't have a development lifecycle where we did all this. Now we have a supposedly working finished product. Well, now the security team can come and, think like an attacker and work on the final product and look for bugs on a thing that actually works, that's not buggy, that they have enough, production samples to build a test harness for fuzzing, all of these things. That's not how things work, because the way they work is like SDLC. Security has to be done in parallel. And that means that security is being done from scratch all the way up to, final shippable product ship. And so that means that your entire time as the defender, you're working on essentially a work in progress product. You're working on something that's not working, that you don't have enough samples for to, like I mentioned, build fuzz farms and these things. So at the end of the day, you're supposed to be finding bugs that, by the way, will be added later. And so that's about it. And I'm going to skip this because we're way over time. And I think with that, I would like to thank you for your patience and your attention. And we probably don't have time for questions now, but we'll see. In any case, thank you very much and enjoy the conference.